Yo, what's up, guys? Welcome back to another video. And today we're going to be talking about the product and the quotient rule. And so essentially what these rules are is in calculus, when you take derivatives, you've learned about the power rule, you've learned about just the power rule essentially. But you would know that in order to take the derivative, say you had x squared, you would just bring it down, minus 1. So your derivative of x squared is just 2x, right? Well, it becomes a little more complicated once you get figures like this. So to take the derivative of this, you might just say, well, we might just take this 2x e to the x and call it a day, right? That's wrong. Don't do that. We need to take the derivative of, let's say x was f of x and e to the 2x was g of x. In order to take the derivative of this function, if this is equal to h of x, h prime of x, and this is what the product rule is the derivative. Oh, well, it doesn't matter, but essentially what I like to do is always have the first function, just the first function, times the derivative of the second function, plus the first function, times the derivative of the first function. Essentially, this is what power rule is. Since you have two functions and you need to take the derivative of both functions, you cannot just take both functions and just take the derivative of them. You have to take, the derivative of one and keep one and multiply them together and then add the other combination. And you might be wondering, well, this sounds confusing. It kind of is, but it gets easier once explained. So let's take that same function, x squared times e to the 2x. So if we were to take the derivative of this, remember, keep the first function the same. So it'll be x squared times g prime of x. And if you know the derivative of e to the x is just equal to u prime, or e to the u is just equal to u prime e to the u. So essentially, since our u in this situation is 2x, u prime would be 2. So it will be times 2 e to the 2x plus, keep this one the same, e to the 2x, plus take the derivative of x squared, which is 2x. And this is essentially your derivative. You don't need to do anything else after this. At college level, I believe you don't have to simplify. Well, at least for my class anyway. And so let's take a look at another product rule you might have to do. Let's say h of x is equal to x to the third times x to the ninth. From here, what you would want to do is just use power rule, because you see that these are two functions being multiplied together. So you would take h prime of x, which is equal to x to the third. Remember, take the derivative of the second function, plus x to the 9, and then take the derivative of the first function. And you would say you would leave it like that. But let's simplify a little bit, shall we? Let's say we have 9x to the 8th times x to the 3rd. Since we know our exponent rule of x to the a plus b is equal to x of a times x of b, we can say that this is 9x to the 11, because 3 plus 8 is 11, plus x to the 9 times 3x squared. You could say this is 3x to the 11. Adding these up, you get 12x to the 11. But oh wait, you could have just done that from the beginning. You see what I mean by you have to be careful in calculus? Sometimes you can do a lot of work with very minimal results when you could have just done it much easier from the beginning. That's essentially a sneaky way that many professors or teachers will try to get you to use power rule. I mean, not power rule, product rule. But in this case, you can just use the exponent laws or exponent thingies and just do it simpler from there. I think a last example for product rule. This is a good one. So let's say we had h of x, which is equal to natural log of x times e to the 2x. So from here, it's the same old thing. You would just take h prime of x, which is equal to natural log of x times 2 e to the 2x plus e to the 2x, and then natural log of x is just equal, the derivative is just equal to 1 over x. So from here, if you really want to simplify, you could just do 2 natural log of e to the 2x. Ooh, don't do that. Don't do that. That's gonna mess you up. Plus e to the 2x over x, and this is your answer. And now we're gonna get into quotient rule. Quotient rule is essentially a similar thing. It's just when you have an h of x, and then you have an f of x over g of x. So from here, in order to take the derivative, h prime of x is equal to g of x, and we're going to put parentheses here because it's kind of long, but it's g of x times f prime of x minus f of x times g prime of x all over g of x squared. Here's what I mean. Let's say we had a very, very famous function that most of you will be asked to derive, h of x, which is equal to 1 over x. Yeah, sure, you could just do power rule, yada yada, and that's your derivative. But in order to show you how the quotient rule functions, I want to show it to you to a more simpler way. So in order to take the derivative, you just follow this baseline. So h of x, h prime of x, g of x will be the same. And in this case, g of x is our x. So it'll be x times the derivative of 1, which is just 0, minus f of x, which is just 1, times the derivative of g of x, which is just 1, all over x squared. You can see here this just turns into 0. 1 times 1 is just 1. And then from here, since it's negative, this is negative 1 over x squared. So let's get into an actual example. Let's say you had g of x, and you had e to the 2x all over x to the 5th. You would just do the same thing. You would write out your little thingy. So g prime of x in this situation, again, you bring it up to the top. You bring x to the 5th on top. So it'll be x to the 5th times the derivative of e to the 2x, which is 2e to the 2x, minus e to the 2x times the derivative of x to the 5th, which is just 5x to the 4th, all over x to the 5th. And this is a 5x to the 4th, in case you can't see. Reason why I'm saving so much space is because now I want you to do this. Let's say you had x to the 5th over natural log of x. From here, you would just do the same thing. H prime of x is equal to, bring the function up. I forgot to put the square here. Ooh, you see, I almost got my, you see me tricking you like that. Don't forget your mistakes. Do not forget that square at the bottom. But essentially, h prime of x of this function is just natural log of x times 4x to the 5th, 5x to the 4th, I'm sorry, minus x to the 5th times 1 over x, all over natural log squared. And let's make it fun. Let's find h prime of 1. If you're smart and you see a pattern already, or you see something, you should already know what it is. But in this case, let's just do it. So we have natural log of 1 times 5x to the 4th, or well, 1 to the 4th, minus 1 to the 5th times 1, because 1 over 1 is just 1, all over natural log of 1 square. If you know your natural log, you will know that natural log of 1 is just equal to 0. So this whole thing is just equal to 0. So essentially, this is just a really, really base oversimplification of product and quotient rule. This is how my brain understands it. And so this is just a quick introduction to what product and quotient rule is. And we're gonna go through one more example, one that's very, very fun. Let's say you had h of x, and let's say it was equal to x to the 5th times 4 e to the 5x all over 1 over x. I might get this one wrong. Never mind, you can't even do that. You can't even do that. Wrong example. But let's say you had x to the 5th times 4e to the 3x. This is a 3. All over e to the 2x. Why not? So from here, h prime of x is equal to e to the 2x. And remember your product rule. This is product rule. If you want to take the derivative of the top function, you have to do product rule. So it'll be x to the 5th. Then take the derivative of the e function. So it'll be 12e to the 3x plus 4e to the 3x times the derivative of x to the 5th, which is just 5x to the 4th. Then you still have to do your minus. So I'm gonna write it really, really slow. 4e 3x times x to the 5th times the derivative of the bottom function, which is 2e to the 2x, all over e to the 2x squared. And that is your derivative. Obviously, you're not going to simplify all that, and I wouldn't recommend you to. It takes too much time, and it's a lot. It truly is a lot. But essentially, this is just a base oversimplification of what product rule and quotient rule is. It gets very, very simple once you do a lot of examples. But hopefully, guys, you like this video. Please like, subscribe, share. You know, that really helps me a lot. So I thank you for it. And, you know, hopefully y'all like this video. If I didn't make any mistakes, please comment down. But this has been product and quotient rule. Thank you, and goodbye.